Immersion and practice is our priority. We've created interactive cases and projects for you to apply your knowledge.
We are recording the data here. That is the daily return, the natural logarithm of daily returns, or the price change, the daily change in prices from day 1 over day 2, which gives you a return, a continuously compounded return, but that's what you need. That is 246, 248, 16, 32, 64, 128. The data is supposed to be up to 1,024 data points. It's a bit less, so it's not quite. There's a bit of accuracy lost. Now they're split according to that. According to, you can see the color coding of each data point. And then there's the transformations, log 10, variation 2, log 10 C8, the Y plot, log 10 C11, and C11 is the deviation squared of this table's SPI history of rate 2, and the next one's rate 4, so on. And that is used in this formula down here. You can reproduce it with a regression over here, which I've got a regression here. I reproduced that data and put it into a regression, got the output, got the line fit plots. Slightly less on the regression. It shows the error greater from the data points missing. And the slope is calculated manually, J10 minus C10. That's J10 minus C10 over J9 minus C9 over J9 minus C9. Which gives you the slope. And to get the actual amount, you divide the slope by 2 to get the Hurst index. Okay, thanks.
Here we create in R a simple RS Hurst rescaled range with a custom function. Then we load the TS features library and run the Hurst command on QQQ data for over 10 years, I believe, back to 2007, followed by Hurst spec command from the Pragma library. The results are not identical as they all use slightly different algorithms and have different rounding computations. The Hurst XP command from Pragma produces not just a simple RS rescaled range, but various experimental and bias correction algorithms. I suggest you read the documentation further if you wish to look at the more complex variations.